Yeah, hi guys. This is Dr. Kang's math time. Yeah, this series. Today I will start I will start to restart to record my YouTube clip for grade 12 and year 13 only because yeah, their final is coming soon. It's around 5 weeks later now. I think that's why I just select some of the small topics. And then I'll try my best to explain the small topics as effective as possible. Okay, the first topic here I select is binomial expansion. What is binomial expansion? Okay. Oh yeah, this clip is only for HLAA. Okay, HLAA only. Binomial expansion. Okay, binomial. We have two terms and then we need to expand it. That's the meaning of binomial expansion. Okay, a plus b to the power of 0, that is 1. A plus b to the power of 1 is just a plus b. And then a plus b to the power of 2, that is a squared plus 2ab plus b squared. A plus b to the power of 3 equals to be a cubed plus 3a squared b plus 3ab squared plus b cubed. And then one more time, okay, to the power of 4 goes to a to the power of 4 plus 4a cubed b plus 4a, no, 6a squared b squared plus 4ab cubed plus b to the power of 4. And then, and so forth. Yeah, we can have. At the end, the purpose of this topic is we want to know how we can expand this general the binomial expression a plus b to the power of n. There is a formula. Okay, the first one is nc0 a to the power of b to the power of something, right? We copy this 0 on top of b, and then the rest we can write here. Once we add those two, then it will become to be this number, right? So that the next one is nc1 a and b. We have b to the power of 1 and then n minus 1, right? If I write one more, a, b to the power of 2, a to the power of n minus 2, blah, blah. And then what is the general term? And no, r, okay, ncr, then what is the form here? A and b is still there. A to the power of r. I said we need to copy this number to there, right? And then make those two numbers to make this n, so that this one is n minus r. Then the last one is ncn a to the power of n b0. No, opposite. B to the power of n a0. This is the binomial expansion, right? So the key here is, okay, you need to remember the general term, how to write it. And then the total number of terms. After the expansion is n plus 1 terms are there. This one is the thing you should remember. How many terms? Yeah, n plus 1 terms are there. That's all. It's too easy, right? Okay. Then I'll go and check the example with you. Binomial expansion. The first example I can use here is something like this. No, this is too powerful. That's too easy. 2, 4, 3. If you have my book, then you can just refer the question number 2, 4, 3. If you don't have my book, then it doesn't matter. Just you see this. Okay, define the constant term and the expansion of blah blah. The first thing you need to do is write the general term. What is the general term? I said, okay, we have to the power of 12 here, so that you write 12. And then general term, okay, we write general term with the letter R. And then the first one is 4x squared. You just copy the first one. And then the second one, negative 3 over 2x, right? And then I said, okay, we copy this r to there, and then make this r, and then here to make 12, right? So that 12 minus r is there. Yeah, this is the shape of the generator. But after we write this generator, what we need to do is we need to split the number and then x's. All the x, yeah, we select, we merge together, and then all the numbers we write in front. Then 12 cr is number, right? And then the next number is 4 to the power of 12 minus r. And then another number is here, minus 3 over 2, right? So then minus 3 over 2 to the power of r. Yeah, up to here is just numbers. Then the rest is x. Okay, x squared to the power of 12 minus r. X to the power of negative 1 to the power of r. So then minus r. Making this step is kind of index low, exponential low. If you are not really familiar with those steps, then you go and check the exponential low or index low. Okay. Then the next step is for constant term. The question is asking what is the constant term, so that we don't need to have x, right? So that make this term to be disappeared, make this much to be disappeared, right? How? Make the exponent to be 0. Yeah. 2 12 minus r to be 0. Then r goes to be, is it 8? Then what is the term itself? Since we got r is 8, so 12 r, no, 12 8, 12 c8, and 4 to the power of 12 minus 8 is 4, times minus 3 over 2 to the power of 8. This is the answer. You can get the answer by calculator. Because this is paper 2 question, right? Yeah, this is paper 2 question. At the end, you can use your calculator to calculate the number itself, actually. Okay, this is the most basic question about the binomial expansion. Then the next one is something like this. Okay, single expansion together with the another term, like, yeah, like 244. Is it? No. Yeah, I select 240. Second question I will show here is the number 240. Expand and simplify to the power of 4. If, yeah, you have the question like to the power of 3, 4, 5, up to 5, I think, yeah, or 6, whatever. We can remember the so-called the Pascal's number, right? 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Yeah, those numbers you can remember. Then you can use it. So number A, expand and simplify x minus 2 over x to the power of 4. The first coefficient is 1, and then the first one, the second one, 0 and 4, right? Then second one, okay, we need to have coefficient of 4, x to the power of 3 minus 2 over x to the power of 1 plus 6 x to the power of 2 minus 2 over x squared plus 4 x to the power of 1 minus 2 over x to the power of 3 plus 1 x to the power of 0 minus 2 over x to the power of 4. Then if you summarize this, how x to the power of 4 is at the very beginning x squared minus 8, 24 plus 32 minus, and then 16, is it? Yeah. And then what I want to do with you is actually the second one. Hence, determine the constant term in the expansion, blah blah. 2x squared plus 1, and then x minus 2 over x to the power of 4. What is this? X, is it still going on? Yes. Sorry. X minus 2 over x to the power of 4. Since we know what is the expansion of the second, the factor, yeah, we just plug these merge to there. 2x squared plus 1 times x to the power of 4 minus 8x squared plus 24 minus 32 over x squared plus 16 over x to the power of 4, something like this. And then we expand. Okay, if we multiply this, we have x to the power of 6, right? 2x to the power of 6. And then where is x to the power of 4? Here and there. Plus 1 minus 16, so minus 15, right? And then the next one is okay, x squared. We have x squared. Here we have, and then here we have, right? 48 plus 1, 49. And then constant term, 24 minus 64 minus 40. What is next? There is x to the power of negative 2, yeah, 1 over x squared term, minus 32. And then the first and the last 32, yeah, it is disappeared, right? So no x to the power of 2, because if we multiply this minus 32, if we multiply this plus 32, so that is disappeared. And then x to the power of negative, for that would be the last one, right? So that there is plus 16 x to the power of 4. Yeah, this is the expression. No other way. Since the question is asking, okay, then hence determine the constant term in the expansion. Well, we have constant term. So that the answer is negative 4, right? This is method 1. But if okay, then I can make like this the question: 2x squared plus 1 x minus 2 over x to the power of okay, let's say 14 instead of 4. Then should we expand everything? Then oh, we should have 15 terms over there. It's too much, right? So in that case, in order to find the constant term, we need to calculate only two things. Since we have x squared in front, yeah, we need to find where is x to the power of negative 2. And then we have 1 there, so that where is constant. So that we need to find those two terms on x minus 2 over x to the power of 14 is there. What is the general term? As we did just before, 14r x to the power of 14 minus r minus 2 over x to the power of r. And then number, yeah, we select, we collect all the numbers first, and then x, merge all the x, 14 minus r minus r. For constant term, 14 minus r goes to be 0, that's why r is 7. For term in x to the power of negative 2, 14 minus r goes to be negative 2, that's why r goes to be, is it 8? Yes, 8. Then Let me summarize the constant term here first. So constant term is 14c7 minus 2 to the power of 7. That's constant term, right? And then term in x to the power of negative 2, 14c8 minus 2 to the power of 8, x to the power of negative 2. Then what is the, how is the original equation now? 2x squared plus 1, and then x minus 2 over x to the power of 14 goes to 2x squared plus 1 times blah 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 plus constant 14 7 minus 2 to the power of 7 plus x to the power of negative 2 14 8 minus 2 to the power of 8 x to the power of negative 2 plus blah blah blah. We can have other terms, but in order to get the constant term after the multiplication, what we need to have is just those two, right? And then once we multiply like this, we have the constant term, and then once we multiply like this, then again we can have constant term, right? So that constant term can be 2 times 14c8 minus 2 to the power of 8 plus 1 times 14c7 minus 2 to the power of 7. This is constant term. So in summary, what I can say here is, okay, at the very original question, we have only 5 terms, right? So that doesn't matter. You can just expand everything and then try to find, oh, where is constant? But what if we have so big number like 14 on the second term? Then we can, we don't want to expand everything, right? In that case, we can have probably 15 terms. Yeah. So that what we need to do is first we should think which term we need to have from the second one. In that case, we should observe what is in the first one, right? In the first one, we have x squared and then constant. In order to find the constant, we need to have x to the power of negative 2 from the second one, and together, we need to have constant term, right? That's what we have taught before we start. Then we just solve for the second one only to find constant term, and then term in x to the power of negative 2, and then you just write in this form, then try to get the constant term only. Then make the question much easier. Okay, that's the usual, typical, one of the typical example in binomial expansion question. Another very typical example is this one. Even this question is in paper 1, which means you don't have your calculator there, right? Then they ask us to find the exact value of 2.1 to the power of 4. So that multiplying 2.1 4 times is a bit tricky, right? And then the question they have the word hands, so that we must use the fact from number 8 question, right? Write down and simplify the expansion of blah blah. Okay, we do anyway number 8 question first. 2 plus x to the power of 4 goes to 2 to the power of 4 plus 14641, right? The next one is 4. 2 to the power of 3x plus 6, 2 to the power of 2x squared, 4, 2 to the power of 1x cubed, plus 1 times 2 to the power of 0, x to the power of 4. So that in simplified form, 16, 32x, 24x squared, 8x cubed, plus x to the power of 4. That's the answer for number A. Then number B, how we can calculate 2.1 to the power of 4? If x is 0.1, that's the key. If x is 0.1, then your left hand side goes to 2 plus 0.1 to the power of 4 is 2.1 to the power of 4, right? Then instead of multiplying this 4 times, yeah, we can utilize the expansion of this. Your right hand side, x is 0.1, then we can get 2.1 to the power of 4. So that we plug x to be 0.1 into the expansion, then 16 plus 32 times 0.1, 24 times 0.1 squared, 8 times 0.1 to the power of 3, and then 0.1 to the power of 4, which means 16 plus 3.2. This one is 0.01, right? So that is 0.24, 0.008, and then 0.0001, right? Okay, 16, 3.2, 0.24, 0.008, 0.0001. So the answer goes 9.19.4481. Okay, this is the exact value. So yeah, it can be 2.1, sometimes it can be 1.9, right? Okay, yeah, that's all. Previously, which means before your curriculum has been changed into the new one, yeah, those are the only questions. But since yeah, you are the first year students after the curriculum is changed into the HLAA, right? There is additional stuff about the binomial expansion of this. What is that? So far, what I have explained is a plus b to the power of n. In this case, n was positive integer only, right? But we need to extend, yeah, this into the a plus b to the power of p, and then p is actually real number. Wow. For example, a plus b to the power of half, which is actually square root of a plus b. Can we expand this? Yes. How? I will explain now. This is related to the Maclaurin series. Yeah, I will later maybe have some time to explain about this Maclaurin series as well. But here, this is binomial expansion. So the basic form is 1 plus x to the power of p. What you need to do is just remember this formula. In order for me to explain this to you, then I need to get the theory from the Maclaurin series expansion. But today I don't want to have that. So what I want to give you today is, okay, I write down the formula here, and then what you need to do is just remember that. Before I start to explain the formula here, I'll give you one tip that is about the combination. Previously, yeah, in our formula of the binomial expansion, yeah, I wrote NC0, right? NC1, NC2, I write a bit more, 3, NC4, those things, yeah. What is NC0? That is actually NC0. It's the same thing, right? Yeah. How to write that? No. This is what you need to just remember. NC0 is 1. NC1, we start from N, then we start from 1 on the bottom. How many numbers there? Yeah, we have only 1 numbers are there. NC2, we start from N and then 2. How many numbers? Yeah, we have 2 numbers are there. So the 2 times 1, N times N minus 1. It is decreasing, okay, sequentially decreasing by 1. So N after that is M minus 1. After that is M minus 2 or something like that. It just decreased by 1, right? So the NC3 goes 3 and N, M minus 1, M minus 2, 3, 2, 1. That is NC3. NC4, how to write? n minus 1, 2, 3, 4 numbers are there. 4, 3, 2, 1. Okay, so for example, 10C3, how to write it? There's 10C3, right? 10 and 3 here. 9, 8, 2, 1. 15, 4, 15, bottom 4. We have 3, 2, 1, 14, 13, 12. That's the answer. Yeah, that's how we write the combination. Then I write down 1 plus x to the power of n first. That is previously, okay, I explained like this. nc0, 1 to the power of n, x to the power of 0, right? Plus nc1, 1 to the power of m minus 1, x to the power of 1. nc2, 1 to the power of m minus 2, x to x squared. I think I better to move this side a bit more to the right hand side. Okay. Plus nc3, 1 to the power of m minus 3, x to the power of 3, blah, blah, blah. I wrote something like this, right? In that case, we have fixed terms. Previously, I said how many terms are there? Okay, n plus 1 terms are there, right? But in this, okay, now we have p instead of n. P is real number, I said, right? But the writing is exactly the same. Okay, I move this down a bit more before I write this formula. Yeah, I will use the previous one. nc0 was what? That's 1. 1 to the power of n, x to the power of 0. nc1 is what? n, correct? 1 to the power of n minus 1, x to the power of 1 plus. nc2, yeah, we just learned, right? 1 to the power of n minus 2, x squared. nc3, okay, 6, 3, 2, 1, n minus 1, n minus 2, x cubed plus blah, blah. That's why 1 plus x to the power of p is very similar. Very similar. Okay, we can ignore one blah blah, right? Then the coefficient is 1. Coefficient is 1. N, nc2, nc3. And then x to the power of 0 is just 1. X squared, x cubed. Yeah, we can write in that sense. So that the first one is always just 1. The second one is, okay, p times x. P times x. Okay, every n is substituted by p. That's all. Second, the third one, 2 factorial. Instead of 2, yeah, I just write 2 factorial, okay? P minus 1, x squared. The next one is 3 factorial. P minus 1, P minus 2, x to the power of 3. Then the next one you can, yeah, easily write here, right? P minus 1, P minus 2, P minus 3, x to the power of 4. And then this one is infinities. We have infinitely many terms. This is the formula. So example, okay, try to expand this 1 plus x. How? Oh, this one is 1 plus x to the power of half. Then 1 plus half x plus 2 factorial half minus half x squared. 3 factorial half minus half minus 3 over 2 x cubed plus 4 factorial half minus half minus 3 over 2 minus 5 over 2 x to the power of 4 blah blah. Do I need to simplify this? Okay, try. 1 plus half x minus 1 over 8 x squared. 3 is gone, 2 is gone, and then plus 1 over 4. Is it correct? No. Root 16. The next one, okay, we have 3 and 5 on top. I mean, we have 3 minuses, so that it's negative. 15, 3 is gone, 5 on top. On the bottom, 2, 2, 2, 2, 2, 4. 7 twos. 2 to the power of 7. 1 to 8. This is the expansion. Then immediate example is, okay, what is the 1.01 into 3 decimal blah blah. Yeah, those kind of question is actually very stupid, you know, because we can have calculator in that moment so that we can put this into the calculator, but you need to show you're working, right? So how? If x is 0.01, then 1 plus x to the power of half goes 1, no, 0.01 to the, oops, 0.01 to the power of half goes 1 plus half times 0.01 minus 1 over 8, 0.01 squared, blah 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 blah. Yeah, then you can calculate this, right? But sometimes, yeah, people can make it. Yeah, really, people can make it. The denominator here can be a very good number to calculate by decimal, so that I don't know whether, yeah, it can be on the paper one or not. Anyway, this is another example. You can calculate the exact value of this by your hand up to this certain decimal. That's the first question. Okay, then the second question. Instead of 1 plus x, okay, for example, 1 over 1 plus x squared, okay. Yeah, we do like that. Then expand these into the polynomial. That's something like Maclaurin's question. But how? We rewrite this, okay, 1 plus x squared to the power of negative 2. Then now we can apply our formula. The first one is 1, right? The second one, px. In this case, x is x squared, right? So the p is minus 2. So minus 2 times x squared. Next step is plus 2 factorial, minus 2 minus 3, and then x squared squared. 3 factorial minus 2 minus 3 minus 4 x squared cubed. It's easy, right? Yeah, I hope, I believe everybody can do this. Then the last concept, last example can be like this. Instead of 1, in front we have, okay, we don't have 1. We can have different number like 2. Then, okay, for example, 2 plus x to the power of cube root of 2 plus x. How we can expand this? Oh, sir, my formula was, oh, okay, starting with 1 only. But in this case, okay, the starting is 2. Then how? Of course, we can bring 2 out of the bracket. 2 plus x to the power of 1 over 3, right? Then I want bring this out of the bracket. Then how? 2 times 1 plus half x. It's the same with 2 plus x, right? And then to the power of 1 over 3. And then by the exponential, the index law, 1 over 3 can apply to the 2, and then 1 plus x over 2 to the power of 1 3, right? Then now we can expand, okay. 2 to the power of 1 over 3, we leave just in front out of the bracket, and then we just expand this much only. Then the formula goes, okay, 1 plus 1 over 3 times half x plus 2 factorial 1 over 3 minus 2 over 3 2x squared plus blah blah blah. This is the expansion. Okay, I think, yeah, those are the most basic concepts And then things you need to know about the binomial expansion, especially the later part, this one, which is about the binomial expansion with the real coefficient, right? That is one of the most important thing here now, because the curriculum is just changed, and then Maclaurin series, and then these extended binomial expansion things are newly included in your new syllabus, so that I can say there is a higher chance, yeah, for you to be able to see this on your exam. Okay, if you want to have this note, then okay, draw back your clip into the previous part, and then you write by yourself. I don't want to pass this to you. Okay, this is the first time of Dr. Kang's math for grade 12 in 2012. Okay, this is the end. Bye.